Welcome back, dear children. Now we will move to section C of the chapter. Okay, so that is equations of motion. For a uniformly accelerated body, we have three equations which are known as equations of motion. Okay, so these three equations are very important. You should by heart these three equations and you should learn its derivation also. Okay, these three equations actually connects initial velocity, final velocity, displacement, time and acceleration. Okay, so for a body moving with uniform acceleration, we have three different equations, and these equations are known as the equations of motion, and it is named as equation 1, equation 2 and equation 3. These equations actually relates velocity, acceleration, time and displacement. Okay, so the first equation, and before that, here we are considering a body moving with an initial velocity u. Okay, already I told you, u, small letter u stands for initial velocity. So we are considering a body moving with an initial velocity u. After time t seconds, what happens? Its velocity became v, small letter v. Okay, let A be the acceleration produced on the body and S be the displacement of the body. Okay, so this is what here also, children, it is better to write the lecture note. Okay, in this section we will be discussing only about the equations of motion and their derivation. So no other question can come from this part. Just either they will ask for the equations of motion or they will ask to derive the equations. Okay, so you can write lecture note, no need of question answers. So I told you we are considering a body moving with an initial velocity u. After time t seconds, let the velocity produced or the velocity of the body be v. Then let A be the acceleration on the body and S is the displacement. So we are having the three equations of motion. V is equal to u plus at. S is equal to ut plus half at square. And v square is equal to u square plus 2as. These are known as the equations of motion. So write it in your book, by heart it now itself. During the Google Meet, I will be asking these equations to each and every one because it is that much important. Without knowing the equations, we cannot do the numericals and we cannot move to the next chapter. Okay, so please be thorough with these three equations. V is equal to u plus at. Final velocity is equal to initial velocity plus acceleration into time. This S is equal to ut plus half at square. Displacement is equal to initial velocity into time plus half into acceleration into time square. V square is equal to u square plus 2as. Final velocity, square of final velocity is equal to square of initial velocity plus 2 into acceleration into displacement. Okay, so write the heading as equations of motion and write the condition what I said. After that, write all these three equations. Okay, so when you write at that time itself, please try to by heart this. Equations of motion is very important. Okay, so which are the equations? V is equal to u plus at, S is equal to ut plus half at square and V square is equal to u square plus 2as. Now, the next thing is to derive these three equations. Okay, there are two different ways to derive this. One is using a graphical method and the other one is direct derivation. Okay, so we are going to derive these equations directly. Okay, so no need of graphical method. Two methods are there. They won't ask you to derive in a particular method. Only it will be asked to derive the equation. So we are using the simplest one. That is direct derivation. Okay, for these three equations. So first we will move to the derivation of the first equation of motion. So what is our first equation of motion? V is equal to u plus at. So when you are deriving these equations, first you should write. Consider a body moving with an initial velocity u. After time t seconds, let the new velocity be v and let the acceleration on the body be a. Okay, so these things should be written first. Then only you have to go for the derivation. So, is it clear? So, we will start with the first one. What is the equation to calculate acceleration? Acceleration is given by change in velocity by time, isn't it? Change in velocity by time is acceleration. That is, A is equal to. Already we told that the body was first moving with a velocity u and after time t seconds it became v. So, what is change in velocity? Change in velocity means it is final velocity minus initial velocity by time, isn't it? Standard equation for acceleration is change in velocity by time. Now, change in velocity means it is final velocity minus initial velocity. So, how much is our final velocity? We already told that the body is moving with a velocity u and after time t seconds it became v. So, the final velocity is v, initial velocity is u and time is t. Okay. Now, I'm just cross multiplying this. So, when I cross multiply this, what happens? T will come to this side and v minus u in the other side. A into t is equal to at, v minus u, and here it is 1, isn't it? V minus u. Now, what am I going to do? I'm going to keep v here. Okay. V is kept there and here I have u. It is minus u. If it is taken to this side, what happens? It becomes plus u and already we have at. And what is our equation? First equation. If I write u plus at is equal to v, it is same as v is equal to u plus at. Okay. So, once again, first equation is v is equal to u plus at. So, in order to derive that first sentence, what I have to write is consider a body moving with an initial velocity u. After time t seconds, let the velocity be v. And a represents the acceleration produced on the body. Now, standard equation for acceleration is change in velocity by time. But we know that change in velocity is final velocity minus initial velocity divided by time. For us, final velocity is v and initial velocity is u. So, v minus u by t. Cross multiplying at is equal to v minus u, or you can say this I wrote for those who don't know how it came. Okay. So, from here directly you can write v is equal to u plus at. Because u was having the minus sign. When you come to this side, it becomes plus. So, v is equal to u plus at. So, hope you understood this and it is copied into your book. Okay. Now, we will move to our second equation of motion. Which is our second equation of motion? S is equal to ut plus half at square. That is, here we are discussing about distance or displacement. Okay. Now, we already know the equation to calculate displacement, isn't it? So, what is the equation for calculating displacement? Displacement is velocity is displacement by time, or we can write, I'll use the equation, okay. Displacement is equal to average velocity into time. Do you remember this? When you are considering the total average velocity, equation for average velocity is total displacement by total time. So I have written average displacement S is equal to average velocity into time. Now, normally how will we calculate average? Average means adding all the quantities what we have divided by the total number of quantities, isn't it? So, how many quantities are there for us? We have only two quantities, two different velocities, initial velocity and final velocity. This divided by 2 into t. Okay, so once again we are moving to our second equation of motion. In the second equation of motion, we have the distance or the displacement. That is why I started like this. Okay, distance or displacement is equal to average velocity into time. We already know that velocity is displacement by time and average velocity will be equal to total displacement by total time. So that equation is used by us. So I have written it in terms of displacement. Total displacement is equal to average velocity into total time. Now, average means it is always all the quantities. How many quantities are there divided by total number of quantities. Here we are having just two quantities, U and V. So I have written U plus V divided by 2. That will give you average velocity. Total time taken is T itself, isn't it? Okay. Now, the next thing is we are going to substitute the first equation of motion here. What is our first equation of motion? We know that V is equal to U plus AT. Okay. So, I am going to substitute this instead of this V. Okay. So, S is equal to U plus, instead of V, substituting for V, what you will be getting? U plus AT divided by 2 into T. U plus U is 2U plus 2U plus AT into T, isn't it? That is what we are having here. It's better to put a bracket here, else it will go wrong. Okay, this T is common for this entire term. So 2U plus AT into T divided by 2 is S. Okay, so this is equal to, now I am going to separate this. 2U T by this 2 plus AT square by 2. 2 and 2 gets cancelled. So S is equal to UT plus half AT square. This is our second equation of motion. Okay. So once again I'll tell you, we are going to derive the second equation of motion. S is equal to UT plus half AT square. So for that I am starting with the total displacement or distance covered by the body. Total distance is equal to average velocity into time. Average is U plus V by 2 into T. Now what I have done is I have given the substitution for V. We know that V is equal to U plus AT. So instead of V I have given U plus AT. So U plus AT. Then this T is common for this entire thing. That is why I have given the bracket divided by 2. That is also there. Now, what is the next thing? U plus U is 2U plus AT into T divided by 2. Now, 2U into T, I just separated it. 2U into T, 2UT by 2 plus ATT, that is AT square by 2. Well, then these two gets cancelled and you will be getting S is equal to UT plus half AT square. Here there is a chance that here we will won't keep the T for both these terms, and that is how children usually lose mark. Okay, so be careful with this t. This t is common for both the terms. So listen to the video, then try to derive it by yourself. Then it will be thorough for you. Okay. So clear? Now we will move to the third equation of motion. Which is our third equation of motion? V square is equal to u square plus 2as. Its derivation is similar to the second one. Okay. So here also, since displacement is coming, we will be using s is equal to average velocity into time. What all things we have done in the previous case? Similarly, we will be starting this. Displacement, total displacement or distance is equal to average velocity into time. Average velocity means it is u plus v by 2 into t. And from first equation of motion, v is equal to u plus at. Isn't it? V is equal to u plus at. In the previous case, that is in the second case, we have given substitution for v. But in this case, we will be giving substitution for t. How can I write this equation in terms of t? Am I correct? I need this equation in terms of t. So first thing is, I will take u to this side. So this becomes v minus u is equal to v minus u is equal to at. Now I need it in terms of t, means t is equal to v minus u by a. Okay. So I have written first equation of motion in terms of t, and here we are going to give substitution for t. So how will our equation come? U plus v by 2 into, it is v minus u by a. Okay. Now, how will we solve this? We have an identity for this, isn't it? In maths, you have learned different identities. Here, u plus v, or shall I write it as v plus u? If I write u plus v or v plus u, both are same. Okay. Isn't it? Both are same. Now, did you understand what can I do here? A plus b into a minus b is a square minus b square, isn't it? This is the reason why I just changed. If you write it as u plus v or v plus u, both are correct. Here, since it is v minus u, I wrote it as v plus u. So, a plus b into a minus b is a square minus b square. So, what will you get here? B square minus u square. And since it is multiplication, directly you can write what is given in the denominator, isn't it? So, s is equal to b square minus u square by 2a. So, if you want, you can write a plus b into a minus b is equal to a square minus b square. We have used this identity in order to solve this. Okay. So, v plus u into v minus u is equal to v square minus u square. 2 into a is 2a. So, we got it as s is equal to v square minus u square by 2a. Cross multiplying, what you will get? V square minus u square is equal to 2as. Or v square is equal to, when I take u square to the other side, it becomes plus. This is already positive. So, what is our equation? V square is equal to u square plus 2as. Is it clear? So, once again, our third equation of motion is v square is equal to u square plus 2as. So, we will write for the total distance or the displacement, which is average velocity into time. That is u plus v by 2 into t. From the first equation of motion, we have v is equal to u plus at, and I got what is t from this. Okay, I wrote the equation in terms of t. T is equal to v minus u by a. So I have given the value. I have substituted the value of t in the equation. Now it came in the form of the mathematical identity. A plus b into a minus b, which is equal to a square minus b square. So here I got b square minus u square by 2a. Now just cross multiplying, you will be getting it as b square is equal to u square plus 2as. So I hope all the three equations are clear. So listen to the video. After that, try to derive it by yourself. Three equations plus their derivation is very, very important. Clear? So these are our three equations of motion for a body moving with uniform acceleration. Okay, that also should be there in your mind. These equations are the equations of motion for a body moving with uniform acceleration. B equal to u plus at, s is equal to ut plus half at square, and v square is equal to u square plus 2as. Now we have two cases here. The first one, okay, is if the body is initially at rest, or if the body starts from rest. If a body starts from rest, okay. If a body starts from rest, what happens to u? U will be equal to 0. If it starts from rest means initial velocity of the body will be 0, isn't it? So, how can we rewrite this equation? If the body starts from rest means initial velocity is 0. So, v will be, u will be 0. v is equal to 80. S is equal to, u is 0. So, this entire term will go and you will be getting half 80 square. And v square is equal to, this will become 0, 2as. So this is the first case, that is equations of motion for a body initially at rest, okay, or a body which starts from rest. In that case, u will be equal to 0. If u is equal to 0, if you are thorough with this equation, directly you can write this. So wherever u is coming, that can be omitted, isn't it? So v is equal to 80, s is equal to half 80 square, and v square is equal to 2as. Now one more case is there, that is case 2. Here, if the body is moving with uniform retardation. So if the body is moving with uniform retardation, how can you write these equations of motion? What change will come there? Negative acceleration is retardation, isn't it? So wherever a is coming, there you should put minus. So you will be getting the equations of motion for a body moving with uniform retardation. So v is equal to u minus 80, s is equal to ut minus half 80 square, and v square is equal to u square minus 2as. So this is the second case. Okay. So first thing is be thorough with the standard equations of motion. Then if the body is at rest, the terms with u can be omitted. If the body is moving with uniform retardation, the symbol in between will become minus. Why? Because negative acceleration is retardation. All the plus a will become minus a. Be thorough with this also. Okay. So, with this we completed section B. In section B, I told you no need to write the question answers. I need just the lecture notes. That is derivation of all the three equations of motion plus these two cases. Okay. So, study it thoroughly and come for the next Google Meet. Okay. Thank you, children.